Hi everyone, myself M. Preetiram, working as an assistant professor in the Department of Computer Science and Business System in Ramco Institute of Technology, Rajapalayam. Today we are going to see about the topic of authentication header protocol, that is we can call as AH protocol. So ensuring authentication is one of the pillars of cyber security and the information security. That's why authentication header is one of the crucial practices. In this PPT, we can see about the what is authentication header is and how it can be useful for our organization. Almost every cybersecurity and our information security experts knows about the famous CIA triad, that is the confidentiality, integrity and availability. These three consist the pillars of the data security. Being one of the crucial parts of data security, integrity ensures that the data is not altered by an unauthorized party. As cyber attackers and hackers put increasingly more efforts on intercepting with the data streams, integrity has been an important portion of an information security. That's why the authentication header gained more prominence. Here we will discuss about how authentication header is used and how it can protect our organization and our informations. So what is authentication header? The authentication header, abbreviated as AH, is a security mechanism that aims to help with an authenticating the urgence of the packets of data that are transmitted under IP conditions, which is also known as a datagrams. Moreover, the authentication header plays a vital role in ensuring the integrity of the information that is being sent and received. The authentication header is mainly a protocol. It is an integral part of Internet Protocol Security protocol suite since it confirms the source of packet or datagram and makes sure that the contents of these packets are not changed during the transmission process. The authentication protocol can be applied in conjunction with the Internet Protocol that encapsulates the security payload, or it can also be applied in a nested way. The authentication header protocol, a part of an Internet Protocol SEC suite, provides the authentication and integrity for the IP packets. It ensures that the data is received from the client sender and hasn't been modified or tampered with during the transmission. The authentication header operates at the network layer and can be used in either transport or tunnel mode. While authentication header focuses on authentication and integrity, it doesn't provide confidentiality, that is we can mention as an encryption. The authentication header is an important IPsec security protocol that provides us the packet authentication and anti-replay services. AH is defined in RFC 2402 and uses IP protocol 51. Authentication header can be deployed in either transport or tunnel mode. Transport mode is generally used when the client host initiates the IP security communication. It is of mentioned as two forms, that is message integrity and source authentication. Message integrity, it means the message is not modified while coming from the source, and the other one is source authentication. It means the source is exactly the source from whom we are expecting the data or an information. We are mentioning as authentication and authenticator. What is authenticator? AH provides authentication and integrity for the IP payload, that is transport and application data, and large portions of IP header, that is depending on the mode and protocol. The fields that are mutable in transit, for example, IPv4 TTL, hope limit, IPv4 header, checksum, link layer addresses, are either zeroed or handled, especially during the map computation, so that forwarding changes do not invalidate the ICV. AH does not encrypt the payload, it only proves authenticity, integrity. If you need the confidentiality, then we have to use ESP. In the further slide, we will discuss about it. So the main features of authentication header is, so first one is authentication. It verifies if the sender of the packet is genuine. Second one is integrity. It ensures that the packet is not modified while the transaction between sender and receiver side. That is mentioned as transit. The third one is anti-replay. It prevents attackers from resending the captured packets. And the fourth one is no encryption. The data is not hidden, it only proves the authenticity of it. Modes of operations. There are two modes. First mode is transport mode and the second one is tunnel mode. In transport mode, the authentication header inserted between IP header and transport header used host to host communication. That is, it protects the transport payload and most IP header fields. And the second one is tunnel mode. The entire original IP packets, that is the original IP header and the payload, is encapsulated as an authentication header payload. A new outer IP header is prepended. Authentication header authenticates the encapsulated, that is we can mention as an inner packets, and the outer header generally not authenticated by that authentication header. And this is the architecture of authentication header protocol. So these are the main things. That is, the first one is the next header. It indicates as the 8 bits, and the second one is the payload length. It indicates 8 bit, and the reserved that indicates as the 16 bit. The next one is the security parameter index, which has 32 bit, and the next one is a sequence number. It also has the 32 bit, and last one is an authentication data, that is the 32 bit. So as a whole, nest header having a maximum length of 8 bits. This layer identifies the nest header that uses the specific Internet Protocol ID. And the payload length is layer indicates to identify the security association of the data transmission, and it works in a conjunction with the security protocol in use and the packet's destination address. The next one is the important one is the sequence number. This layer is very essential since it offers us an protection against the replay attacks. The length of the sequence number may vary, recording factors, but it must be a multiple of 32-bit words. So moreover, sequence number is not allowed to cycle once it is set. So then the main one is an ICV, which is also mentioned as an integrated check value. We will discuss about it in the next slides. So these are the one that I have explained before. So the nest header, it is the type of a nest header, that is it is mentioned as a one of a TCP or UDP, etc. The payload length, it indicates as the length of an authentication header. The next one is the SPI, which is mentioned as the security parameter index. It identifies as the security association. The next one is the sequence number. It protects against the replay attacks. And the last one is the authentication header. That is the MAC for integrity. That is the hash value. It converts the real data into a hash value. That is why the attacker can't modify the data. We will discuss in detail. So first one is nest header. The nest header is a 8-bit field that identifies the type of a header present offered authentication header. In case of TCP, UDP or destination header or some other extension header, it will store correspondence IP protocol number. Like number 4 in this field will indicate IPv4. Number 41 will indicate IPv6 and number 6 will indicate TCP. The next one is payload length. The payload length is the length of an authentication header, and here we use scaling factor of 4. Whatever be the size of a header, divide it by 4 and then subtract by 2. We are subtracting by 2 because we are not counting first 8 bytes of an authentication header, which is the first 2 row of a picture that is mentioned above. The next one is reserve. This is 16-bit field which is set to 0 by sender, as this field is reserved for further use and the future use. The next one is SPI, that is mentioned as security parameter index. It is arbitrary 32-bit field. It is very important field which identifies as all packets which belongs to the present connection. If we are sending data from source A to destination B, both A and B will already know the algorithm and key they are going to use. So for authentication, hashing function and key will be required, which only source and destination will know about it. Secret key between A and B is exchanged by method of Diffie-Hellman algorithm. The next one is the sequence number. This unsigned 32-bit field contains a counter value that increases by 1 for each packet that we send. Each packet will need sequence number. It will start from 0 and will go till 2 power 32 minus 1. And there will be no wraparound. Say if all the sequence numbers are over and none of it is left, but we can't wrap around as it is not allowed. So we will end connection and re-establish connection again to resume transfers of remaining data from sequence number 0. Basically, sequence numbers are used to stop replay attack. In replay attack, if same messages is sent twice or more, receiver won't be able to know if both messages are sent from a single source or not. Authentication data, that is we can mention as ICV, integrity check value. The data authentication is variable length field that contains as ICV, that is integrity check value for packets. Using hashing algorithm and secret key, sender will create message digest which will be sent to receiver. Receiver on other hand will use the same hashing algorithm and secret key. If both messages digest matches, then receiver will accept the data. Otherwise, receiver will discard it by saying that the message has been modified in between. So basically, authentication data is used to verify the integrity of transmission. Also, length of authentication data depends upon hashing algorithm that we choose. How authentication header is used, that is the packet flow that is mentioned in the step-by-step process. Initially sender, look up SA, that is SPI, get the key, algorithm and the sequence counter. Increment the sequence number and insert in AH, that is the authentication header, and compute MAC address ICV over prescribed parts, that is payload and selected IP header fields using the shared key. Then put the computer authentication data in authentication header and then send the packet. These are all done by us. In receiver side, so extract the SPI, that is the security parameter index, and find the SA, that is the key, algorithm, anti-replay window. Then it check sequence number, reject if replay out of the window. Recompute the MAC over the same fields using the key, and then compare computed ICV to authentication data. If match accept, else it will be dropped. How does authentication header works? When a data is sent from a source A to destination B, it includes both data and a header. The authentication header verifies the origin of the data and check if any modification occurred during the transmission. Note that some IP header fields such as the hop count, options and extension headers may change in transit and are not protected by authentication header. Authentication header focuses on protecting essential field within the IP header. So AH adds an extra header between IP header and payload, that is the data. It uses cryptographic hash function like HMAC MD5, HMAC SHA1, SHA256 to create a message authentication code, that is we can mention as MAC address. Both sender and receiver share a secret key. When a packet is received, the receiver recomputes the hash using the shared key. If the hash matches, the packet is authenticated and unchanged. If not, the packet is rejected. So we will see some real-time example. Real-time example 1. Imagine you are accessing your university portal from your laptop through a secure VPN. Your laptop sends us a login credentials, username and password to the university server. The VPN uses IP security with AH to ensure that the packet actually comes from you, that is the authentication. The packet is not modified by the hacker, that is an integrity. Hacker cannot replay your login request multiple times, that is the anti-replay. However, since authentication header does not encrypt the content, someone could still see the data if intercepted. That's why in practice, authentication header is often combined with ESP, that is for encryption. Let's see the real-time example 2. A real-time example of authentication protocol is when two government offices exchanges official reports over the internet using a VPN. The reports are not secret, but it is very important that they are not altered during the transmission. Authentication header ensures that every IP packet has an authentication header so the receiving office can verify the sender's identity and confirms that the data was not modified in the transit. Even if an attacker tries to tamper or modify with the packets, the receiver will detect it. Thus, authentication header provides us integrity and authentication, though it does not offer an encryption. So, what are the advantages and limitations of authentication header? So the advantages is it provides a strong integrity and authentication. It is lightweight since there is no encryption is done. The main disadvantages is it that is no confidentiality. Data is visible to the hacker also. Does not work well with NAT, that is the network address translation, because NAT changes IP header which AH protects. So this is the main difference between authentication header and ESP, that is we can mention before, which is abbreviated as encapsulating security payload. So the main purpose of authentication header is it provides us authentication, integrity and anti-replay protection of the packet. Here it provides, that is the ESP provides confidentiality, that is the encryption, authentication, integrity and anti-replay protection. If for encryption feature, authentication header does not provide encryption, so data remains visible. For ESP, it provides us the encryption, data remains confidential. In authentication, so the authentication header, yes, it ensures us the sender authenticity and data integrity. On the other side, that is in the ESP, yes, it can provide the authentication along with the encryption. So next feature is the IP header protection. In authentication header, it protects us the entire packet including the IP header except the mutable fields like TTL and checksum. In ESP, it protects only the payload data, not the outer IP header. In the next future, it is a protocol number. So authentication header is 51 used in an IP header protocol field. In ESP, the protocol number is 50 used in IP header protocol field. Then the overhead. So in authentication header adds 24 bytes, that is approximately less overhead than ESP. So adds the variable, that is 24 to 32 bytes or more depending on encryption and authentication methods. So the main use cases in authentication header is when authentication and integrity is needed but encryption is not required, that is ensuring packets are not modified and transist. So in ESP, when confidentiality and authentication and integrity is required, we can use the ESP protocol. Thank you so much. As we can see in the other video.